Hi, welcome to my channel, The Machine Learning Engineer. Today we continue our journey with another video on the series RAG, Retrieval Augmented Generation, and the topic of today is how to build a knowledge graph using intelligent agents. We are going to build a pipeline which and will create a knowledge graph into Neo4J, the well-known graph database, using either structured data or unstructured data simply coming from text. My name is Juan. I'm a system engineer with more than 30 years of experience on the IT sector and last 10 years dedicated to projects of artificial intelligence and machine learning. Well, let's go to the topic. First, what is a graph database and what is a knowledge graph? The knowledge graph is just a graph that we create obviously in a graph database. And today, they are roughly used the graph databases like a like a tool that allow us to model uh, very interconnected data uh, and allow us to easily query our data using the capabilities that have our graph database. Usually, for many years, we have been using tabular or relational databases, which are ideal for structured and consistent data with simple relationships. And this, in industries like finance, e-commerce, has been really okay. It's got scale properly, but and when we need to do simple queries, these systems have performed really well. But when you need to do very complex multi-hot queries, or when the data is very interconnected, meaning there is complex relationships in between the data that you have in your tables. Usually, tabular on relational data set doesn't perform very well. You probably remember how we do that using, or how we still doing this on tabular and relational data set is simply creating foreign keys. And at the moment that you need to create queries which imply to access data that you have in multiple tables, this means that we need to join the tables using these foreign keys. This in some cases is simple, depending again how many hops you had to jump in order to get the final information, but if you need to join multiple tables, this imply not only, this degrade not only the performance, because we need to join multiple tables through the foreign keys, also is quite complex even conceptually to do, because imply to know very well the schema of the database in order to properly map or join the tables correctly and find the information uh, that you want to find. In the other hand, graph databases allow us to easily model the data and create uh, complex relationships in between them. So the graph databases have been designed for interconnected data and are really superior at analyzing complex relationships like info detection, social network, or recommendation engines. So this is the way that we organize the data in nodes and relationships in a graph databases is allow us to easily understand the relations that any single entity we have in our data is connected with other entities of the same class, or other entities of different classes. This this concept allow us to simply understand how our data is how to say grouped, clustered in many cases, and also how we can get from one node to another node using the interconnections that we have in between our nodes. So with the evolution and with the growth of the graph databases appears the concept of knowledge graph. Knowledge graph is not more than a representation of your data into a graph. This information, it can be stored in a structured data, let's say tables in a database, CSV files, Excel files, or it can be stored in text, unstructured data, PDFs, text, ND files, whatever. The idea of building a knowledge graph is extract what we know as entities, which represent the data of the organization or the domain area. So in our data, let's imagine that you have that data in a database or documents that are related to your, let's say, products that you have in your company. Essentially, is what we are gonna see this in this demo. You had a number of documents, tables, PDFs, whatever, which explain with the product that your company is producing, how they are built, how they are assembled, which part they had, which supply, which company supply these parts, how many components or how many parts are connected to a component of the product, etc., etc. All this information can be either stored in structured tables, like as I said, tables of a database, CSV files. Today we will work with CSV file. It can be the knowledge can be spread in different places. You can have, for example, data with simply are tables with you don't have any schema of the data. The schema of this data can be explained and in unstructured files in a document which tells you, well, the this table is like the documentation. Basically, this table contains the product, these assemblies, these the parts, suppliers, and this is how we interconnect the different tables and how we can extract for example, how many parts or which suppliers we need to address in order to build these products. And also, it can be simply documentation. You just had a domain. Everything that you need to know from that domain is stored in just document. That will be the case that we have only unstructured text. And the idea in this domain, you have what we know entities. An entity can be a person, can be a product, a part, a supplier. All these entities represent what we know in a graph database, are represented in what we know in a database as node. This node can have an attribute, and then we have nodes of the same type, for example, similar or products. So we have nodes with the name product. This product has some attributes, the metadata. This in an structured data set is represented table products, and every product has a different column, no? In our CSV file or in our table. This in a node in a graph database is a node with the name or a class node with the name product, and each node had an attribute. Then we had the relationship. We show how the data entities interact with or related to each other. Relationships provide context for the data. If you remember in a database, when we want to connect, for example, the products with their parts or with assemblies, we just create foreign keys. The foreign keys they allow us to connect the data products with their assemblies or with their parts and parts with suppliers. And then on this is the connection which tell us, okay, this ID in this table is connected with this supplier, or this ID in this table is connected with this part or with this product, etc., etc. This is the way that how we connect the tables in a database or using data frames or whatever structured um, facility. One second. Sorry for the interruption. And then on, we were discussing about relationships. Relationships, as I said, will show us how the data interact with or related with others. So is the equivalent, as you may know, or you probably know, as the equivalence to the foreign keys and allow us to connect the different entities. These relationships difference that the foreign keys that we use in structured data can have a direction. It can be uh, unidirectional or direction or bidirectional, and also can have weights and can have uh, attributes itself. So this allow us to much more and better model any kind of domain, information domain, and will allow us as well to use well-known algorithms or metrics that are used when we work with the knowledge graph, like sorted paths or communities or clustering, subgraphs, which is a kind of clustering, and many others that are only available in graph databases. So what we are going to do here is we are going to create a knowledge graph using some structured data. We will create a graph, and then on we will be able to query this graph later on with a NCP client. In this case, we will use a Cloud Desktop connected to a Neo4J database. How we build the knowledge graph? The the knowledge graph, we can create it completely in a deterministic way. Just simply we know the schema what we want to create, and we just simply take in this case the structured data. Let me show you a little bit the structured data, and we take the structured data and we just simply create the connections, the nodes with their attributes, and we connect the different, this is the table, farm supplier mappings, bars, and we just simply connect this using heuristics. Simply, we had, like we will see in our application, we had the possibility to just simply read a configuration file, read all these CSV files. You can imagine that these are simply tables in your database, and then on we just simply, as you will see here later, knowledge graph. Let me show you. We had a configuration file, and from reading the configuration file, we just simply say from the products CSV, we create the node product, which we can create as well keys, indexes in the graph databases, and the properties are going to be product, price, and description. If we look at the product, we have product, price, description, and you can see here product ID. You have here as well later assemblies. Oops, let me show you again the application, etc. So this is one way to do it. Just simply you define your schema in a Neo4 in a YAML file, and we load the the nodes and relationships. Here we create as well the relationships, what is going to be the key, etc. We can simply define the schema, how everything is going to be interconnected, nodes and relationships into the graph database. By the way, I don't know if I mentioned, but obviously to do this, you need a Neo4j subscription. You can use Neo4j Aura, it's free. As you can see here, at least for this test is more than enough. You can just create an instance using your email address, and then once you create your instance, you can simply get the values for your graph database. You need the URL, you need the user. Usually the user is Neo4j, and you need as well the password. Once you are creating the instance in Aura, you will get the password. Note it down, the password, because you will not say it again, and this password you will need it to later on. You will need it to configure the pipeline. We configure these values as environmental variables, and this will be introduced in your .env file. So you need to have one. You can use as well Neo4j desktop, the community version. You can use as well, well, whatever version you have in Neo4j. I recommend you, as it's free, you can use the sandbox as well. The sandbox are also possible to use. You can use a free is also free. You have a complete and fully functional graph databases for free for 3 days with an extension of 10 days. I recommend you to use Aura, because once you create an account in Aura, Neo4j Aura, you have it up to you decide not to use it anymore. If you don't use it for 30 days, it will be automatically removed, but you have it there, you can play. If you don't scale to more than 500,000 relationships or more than 100,000 nodes, it's fully functional. And then to just to play with the tool is more than enough, and especially for this exercise, it's not, you don't need more. So this is one option. We will try how to create the graph, the knowledge graph, just using heuristic, a pure deterministic agent. So all of them are agents. We are going to create the knowledge graph using agents. Some of them are deterministic, some other are non-deterministics. And then the non-deterministics are those that are leveraged by an LLM. And then on. The second way that we will use to create our knowledge graph is using an agent which essentially infer or create the schema looking at the schema of the different CSV files, in this case, that we have in a folder. So once uh, we will pass this information, the attributes, the headers of these CSV files, we will load it with pandas. We will extract this information from the CSV file, and we will use an LLM. In this case, it's the schema proposal structured agent. We will use an LLM to propose an schema for from this, an schema for the knowledge graph, uh, reading these CSV files. There is a variant of this later when we use a schema proposal structured agent. We will create the schema using an LLM, or using the knowledge of an LLM, and the data on this CSV will be the data that conforms our knowledge graph. We can do the same instead to read the headers and the attributes of the CSV files. We can use uh, some text, like ND file or a TXT file, which describe how we want to create the schema from the same CSV files. The data is the same, but in that case, we create another agent. We can use one or the other, which use this. The data is going to be the same. The data is exactly the same. We will create nodes and relationships from the same data, but here in this schema proposal structured agent, we use the metadata that has our CSV file, this means headers and attributes, and here we have the same but described in natural language in a TXT or Markdown file. So the schema is going to be inferred for unstructured data, it's a text file, and then we will just read the information in that text file and we will infer the schema of the data in our CSV files, and we will use the description to create a schema, and with this schema we will load later on the data from the same CSV file that use our schema proposal structured agent. And the fourth use case is just simply create a schema and data for our knowledge graph from a unstructured file, ND or TXT file. So we had four modalities, if you want to say that: pure heuristic, pure deterministic. So we just configure in a YAML file the schema or our CSV data or our tables. Secondly, we use an agent which just use the metadata or our CSV files, so these headers and attributes of our data frames to create the schema. The LLM is going to interconnect the different tables. It will propose and create the relationships. We will see that the LLM use different names, different databases that we have on the YAML file. We have another modality where we write down in a TXT or Markdown file how we want to create the schema, like a prompt. We explain we want to the table products contain this and this and this, the table assemblies. We will look at this later, but the data is exactly the same that we have on the CSV files, but how we create the schema is different. One is looking at the attributes and metadata of the CSV file. The other one is looking at the description of these attributes that we do in natural language in a Markdown or TXT file. And the fourth use case is simply we have data and a schema contained in a TXT and in an unstructured data set or unstructured file. We had other agents. First of all, the orchestration agent, which govern the flow of the different agents and control the status of the whole pipeline and transfer data in between the different agents. The orchestration agent has memory and also status, and this status is part of the inputs that we pass from agent to agent. We have a user intent agent, which essentially detect if the intention of the user, what they want to create based on the files that we pass. We want to create a knowledge graph from these files, and this is going to be files for products, file from blah, blah, blah. So it's detecting the intention of the user. We have another agent which essentially look at a folder that we pass as a parameter and understand which files are relevant for the to fulfill the intention of of the user. We had an agent which create an schema based on the structure and metadata of the CSVs proposed by the previous agent, and we had another agent which essentially do the same that the previous one, but uh, inferring the schema from the TXT MD file. We had another agent. This is this these five agents are LLM leverage. So we had an LLM. Uh, they have both options. To be honest, they can be used. Uh, they can be heuristic or deterministic or leveraged by an LLM non-deterministic in this case. The unstructured inject agent is essentially extracting the schema and the data from unstructured data. And we have here the data ingest agent is pure deterministic. It's just simply loading the data according to the schema inferred for one of the previous agents, either deterministic or not deterministic, and this is going to load the data into Neo4J. We had the graph operations agents, which essentially look at the readiness and of the database, look at the version check, can reset the database via all of them via command line, obviously. And we have an agent which controls the schema, the different schema mappings depending on how we are going to create it via structured, not structured, etc. Controls the login as well, and rotate the logins, and controls as well what happened on the console. This is the orchestration and agents layer. We had an initial layer where we had the configuration with YAML files, and end environmental file where we had everything that we need to configure the environment, structured data or unstructured data in different folders, just to where is the folders where we keep the data, and an LLM router, which is this class, is essentially doing a normalization of the AI provider. We can use, in this case, I have set up to use OpenAI or Gemini models. You can extend it at at your convenience, and also create a fallback case of we don't have the correct or it's not possible to create the clients to connect to the SDKs of OpenAI or Google. In that case, is using always a fallback to heuristic. So the full pipeline can be fully heuristic, fully deterministic, and in case that we decide via parameters, and obviously we have the correct API keys on our environment, you can use as well the LLM. The LLM router just will normalize the completions to use it in different providers. And finally, we have the outputs. The outputs gonna be node relationships, constraints, and explorer and node relationship and constraints that will be present in our graph database. So let's go a little bit to the code itself. We have the structure. We have our CLI, which essentially get some parameters from command line. We create our orchestration agent, and depending on the command, we have ingest. This is pure deterministic pipeline. With pipeline can be either deterministic or non-deterministic, so leveraged by an LLM, and depending what uh, the parameters we determine if how to use the different agents. As I mentioned you before, If we pass the argument LLM, it will use every agent that is possible to be used with an LLM. It will use the LLM version. If not, we use it, as I mentioned you, pure deterministic. So here using intent agent, file suggestion, schema proposal and structured. So all of them have the version LLM and version heuristic or pure deterministic. And here we had, this is just simply summarize. Let's just to choose which schema to apply. This is essentially done automatically. And here, well, we have finally the injection schema. Once we have detected which schema to use according to the user intention and the parameters that we have in the pipeline. Then on the final step is obviously rule for ingests with a schema. We have other options that are reset, that is resetting the database and also checking if the database is ready to go. So here we had agents, our agents, we had the data ingestion agents. Again, data ingestion agent is purely deterministic. So here we don't use an LLM, just simply importing the data into Neo4j according to the schema that has been decided on the pipeline. Suggestion, file suggestion, this is obviously using either an LLM, and you can see here we have methods to leverage the process with our LLMs, and we just simply using our LLM router to simply send a completion to the selected AI provider. If not, the tool can be work purely deterministic, just simply reading our configuration file. We have the user intent. Similarly, parse is essentially the user intent, is taken directly from our configuration file, and is not, we use an LLM to determine what is the intention of the user. After user intention, go file suggestion, then on proposal, structured or unstructured. So here we have the same, our propose using the configuration file or our propose using the LLM. All of them are working pretty similar. They are just creating a instance of our LLM router, and then on the router is just simply going to create a wrapper to send a completion to the AI provider. In that case, adapted to create you can see here we are reading the headers of the files and we are sending the files, the map headers in a in JSON. We how to say, we include these headers of the files. We include it into a prompt. We propose an schema and we send this as an instruction to a model that is configured in our LLM router. The same we do using the heuristic version. Unstructured is pretty similar. We have propose. So we are just texting, checking in the file, and here we just simply get the file from the text, and simply this base is we are simply using the same that we use for a pure deterministic, just to pass the same information to an LLM to create the schema, the structured schema. We had the ingestion or structured ingestion agent. This you probably remember. This is essentially using an LLM to create the schema and extract as well the data from the text itself. So we had every agent is designed for the purpose and contains the logic to do the purpose. And we have data ingest. As I mentioned you before, this is not LLM leverage. It only can be heuristic. It's only creating different ways to load depending which kind of technology are you using, it desktop or Aura, and if you want to do it via streaming or not via streaming to ingest the data into the database. Depending on the type of Neo4j database, you may need one or the other. So here you have the base is remote load. It's not you can check if the Neo4j Yuri is one of these two, which means that you are using Aura or you are using a SaaS service with Neo4j, and it's not you can depending if you have as well this configure in your config file. We had here ADK, we had our bridge, our LLM, this is connections or binds to the ADK. We are using agents development kit from Google to create our agents. We already had a couple of videos on the channel which we explain what are ADK and what is possible to do. ADK is a flexible and modular framework for developing and deploying AI agents. While it's optimized for Gemini and Google ecosystem, ADK is essentially model agnostic and deployment agnostic, and is built for compatibility with other frameworks. If you can see here, we are using by default the pipeline with OpenAI models. So you can see here perfectly that, and we are creating an orchestration. This you can use as well Llama Index, Llama Graph, LangChain as an orchestration. Crew AI, you can use many of the available frameworks together with ADK. ADK only is creating uh, the it has only the classes and the methods to run the agents that later on you can orchestrate. You can orchestrate as well everything with the own ADK, the Agent Development Kit, or you can use a third-party orchestrator like we do here. We create our own orchestrator that only grab the ADK runner, which is the class that is essentially doing the invoke of the agent, calling the LLM for a completion, and you can use for that purpose either a third party like LangChain or Llama Index or Crew AI, or like we did today, create our own orchestration using the ADK classes like runner in this case. We had environment just to load our environment variables. LLM, which is creating the class, we have the LLM router, which essentially create a wrapper to allow us to use completions for any, in this case for only Gemini or OpenAI providers, and then essentially what we are doing here is just to create a generic completion method which allow us to invoke models in different providers. And here tools ADK, which allow us to use tools and to use the tool context methods that are embedded in the ADK tools in our um, orchestrator, and to understand it if the tools are providing a success or failure when we are running an agent, an ADK agent. Okay, so what more? We have here agents, ADK, we have our CLI, which essentially you have here. I think we already covered that. So yeah, you have here using intent. Yeah, we covered this already. The config. So this is the data classes. We have Neo4j, ingest source, relationship mappings, app config. We load this method to load our config file and how we are going to handle everything here. Setup, yes, just simply login Neo4j client. This is to connect our database. Yes, it's simply a wrapper of the Neo4j client. We create with the class, we create a connection using the graph database driver, and just simply when we run, we just simply execute a query on the database. You probably remember Neo4j use Cypher. Cypher is a language very similar to SQL, but adapted to the paradigms of a graph database. The orchestrator, that is our workflow planner, the tool, something that you can put at the same level probably of what is doing LangGraph. It's just creating the different agents and orchestrating the full workflow. We had the config, Neo4j client, Graph OS agent, ingest agent, user intent agent, file suggestion, schema proposal, and depending of your parameters, a command line, it will use one or the other. Then we can ingest all our reset graph, and here we have some other utils just to copy files, to work in batch, etc. Config files for app or for unstructured data. Here, the data itself, we have it in this folder. So we have as well in unstructured, we will use these two files to describe the schema, born overview, sourcing policy, and in examples, we just have some well text that to query later on database. In any case, we will here we have an example of our data environment, what you need to create, and that's pretty much all. Let's go to try some of the where is this that was. Let's clear the CLS. Sorry. Let's execute the here, for example, as I mentioned you, the pipeline is fully controlled by the parameters. Here we are simply ingest using our configuration in the YAML file. We point out to the data folder, so where we have the CSVs, and then on here in the YAML file, we have the configuration of our knowledge graph. So it's going to use the configuration we have here to create the knowledge graph. So you just simply connect here. And it's taking a while, obviously, as usual. Okay, so now, yeah, is starting. Let me show you the database. And you have here, we connect our database, and you can see here how it has been created, our graph. So we have here the pink are products. This is a relationship hat assembly to uh, an assembly part. We can expand this as well. This probably has no parts. Let's take another. Also not. Also not. Here we have hash part, another part, and now we can expand this, and this is supplied by a company. So we have created this. This is pure heuristics, no LLM involved. It's just simply we run all the agents involved. Here we run the user intention, pure heuristic, pure deterministic, just looking at the code. This is determined by the parameters that we pass to the CLI script, and then on all the agents now are working pure deterministic. Let's now reset the database, reset to blank. While we can do it directly with a command, I prefer to do it here because this is doing a reset to default. We remove any track here. Any key that we have on the database is just resetting to 0. So let's now, this is structured. Now we are gonna use an LLM. So when we pass the parameter LLM, same configuration, and now schema structured. What is gonna happen here in our pipeline? We will use the LLM to detect the user intent. File suggestion, we will use as well an LLM, an agent leveraged by an LLM to suggest the files. We will use an LLM, we are in the option structured. We are going to use an LLM to propose the schema, and then on data ingest and grab OFs will be pure deterministic. But these three, together with the orchestrator, is an agent as well, but is pure deterministic as well, based on the parameters. These three LLMs will use, three agents will use an LLM to for their execution. So now let's run the pipeline. As you can see here, we are using GPT 4.1. We are using little LLM. Here we had the log of what happened. Let's connect now to the database itself, and here we have the same. If you remember, this is the query that we used before, hash assembly. You can see here that the relationships that the model has created are having different names. So it's not relying on our configuration file to create either the node names or the relationship names. It's just simply reading the structured files, the CSV files, and passing this structure to the LLM, and the LLM itself has created these names. Here we can do the same assembly, and then we can check what we have here, and you can see here that is practically the same. You can check here expand, also the different nodes, suppliers, parts. This is a part of assembly. This is supplied by. This is part of assembly. This is a part. This is an assembly. We can point as well to a product. Okay. Now let's remove as well the database again to test another use case. Let's go again here. Now we are gonna, let me check where I have this because I was running before for start from text. No, this is unstructured, demo structured here, exactly. So exactly. No, this is not, sorry. Let me find where I had this information. Exactly, we have here strat demo. Remember that we are gonna use this file, unstructured. So we are gonna use this file and this file to create a schema. So let's move here and we call our unstructured demo YAML file. The data dir is the same, LLM, schema unstructured, and the text directory is under unstructured. And we will see if every agent, as you can see here, we have the user intent. This is the file selection. Here we have, okay, we are doing the same file selection. Here we have the unstructured agent, and finally we are creating as well the different nodes. Let's check how our database looks like. And we have here essentially the same. Here has assembly. Here you can check this is how is described in our data, in our text file, and at the end is creating the same relationships that we have here. So has assembly, we can check, okay, this node here, expand, we can expand this as well, or we can expand this has nothing, here, okay. And the last use case is just simply let's delete the database again. We are gonna create the data using, in that case, we are going to create is very small. We have only a chair. This chair is has a seat and a backrest. The seat uses phone. The backrest uses phone and fabric, and the screws are supplied by German precision fasteners. The vendors are Brazilian Ford Solution provide phones and German. So we have here some informations. Let's see what the LLM provide to us or create from this. Sorry, let me find out where we had. So now here Python, the same CLI pipeline, unstructured, we have extract from text. This is a new parameter, and we pass the text directory. Unstructured, it had to be the directory, and we use LLM for that. We use LLM agent, o sea, agents leveraged by an LLM. As you can see here, there is only 8 nodes and 9 relationships. Let's take a look what we have created. Connect, query, and here we have as well products, minimum share, expand. You can expand this. Now we will control this and screws. Fabric had no providers and Brazilian firm. Let's take a look to the code. So we have the minimal chairs that have a bus rack and a seat. The seat use foam here. The bus racks use foam and fabric, and also screws, obviously. And the screws are supplied by German Precision, and the phone is supplied by Brazilian phone solutions. Here you can see here, probably more clear. So we have created directly our knowledge graph, just extracting the entities and relationship directly from the text. And now let's run as well the structure, because I want to show you how. Let's click the database again, last time, and we're gonna run again the other model, so the other pipeline using structured or not structured, doesn't really matter. So schema structured, that one, and I want to show you how this works in Neo4 with Claude. So for those that are not familiar with Claude Desktop, just you can set up you can configure different NCP servers. Claude Desktop is the solution, the thick client that you can set up in your computer in Windows or Mac. Also, there is a non-official version for Linux, but I'm using the Windows one, and then you can set up different NCP servers. In my case, I have configured a connection to the database we just showed to this database, and then on to connect these NCP servers to Claude, you have this configuration file with this Claude desktop config.json. Here I will show you right away in a second. opening a notepad, and this file essentially have the configuration of your NCP servers. Here we have the database toolbox. This is something I, I configure for the NCP toolbox. This is a NCP server for Google, which gives you access to all the database offering structured or not structured in Google. This you have it in a previous video, and this is the configuration of our Neo4j. Here I removed what I don't want you to see, but just essentially using universal virtual environment and the connection to the your Neo4j database using the NCP Neo4j Cipher NCP server. So here, once you have this configured in your cloud desktop, you start the Neo4j, you start cloud desktop, you can take a look to the logs. Every NCP server has their specific log file, in case that you had any issues connecting. You can come here and first of all see if the NCP server is running. This is in my case running in both, and then once you had both running, you can come here and configure if you want to use them as part of the tooling that is available for your NCP client. So let's do a test. So you probably know that the Cloud Tester in this case acting as a NCP client. It's more than a client, it's a host, NCP host, meaning that we had multiple NCP clients running at the same time. Every NCP client connect to an NCP server. In my case, I had configured the NCP embedded server, which allow me to do web search, and in that case as well, the Neo4j test. You can add other connectors. Here you can see these are native NCP clients which connect to native NCP servers that are connected or configured on the Cloud AI side. Okay, so now I'm gonna use my NCP client, my Cloud desktop, to query the Neo4j. Let's check first of all if we have data. I suppose that after running, so we had again the initial part of assembly. Yeah, this is again valid. Yeah, let's connect this, expand. Yeah, and we have multiple connections. Let's do a query to our, for example, Neo4j part supplied by American Hardware Inc. So this is going to connect to our graph database. First of all, get the schema and run a Neo4j Cipher query. And you can see here already the parts, the part name, assembly, and the product. So can you list all suppliers, suppliers in the database? It will create another. You have it here. And if you compare with the table, well, I'm 100% sure that is correct. And products. And now you can interact using natural language with your knowledge graph, which essentially we have imported from our structured data or unstructured data. You have already this information in your Neo4j. You can include this either to as a knowledge for any query that you use, or here like you are seeing with Cloud AI or with other technology from other AI providers. And that's pretty much all. Thank you very much for watching the video to this point. I hope that you find it interesting, useful for your job, for your training, for whatever reason are you watching these videos. And if so, just give me a like, subscribe to the channel. If you are not already subscribed, consider becoming a paid member of my channel. This way you have access to all the projects. Practically 90% of the channel is free for use, but only these projects with the name end-to-end projects are only available for paid subscribers. You have all the code available, all the code that I described on the video is available in this case for paid subscribers. We have already 30 end-to-end projects about most of the generative AI, agentic AI, AI on finance and others. And also you can help me making comments on that on the videos and sharing the ones with the videos with the friends and colleagues. That's pretty much all. See you in the next video. Thank you very much and see you soon.